Okay, for this last video, so this is going to be our last section on special parallelograms, rhombuses and rectangles. And so let's just remind ourselves that every parallelogram is a quadrilateral, right? Every parallelogram is a quadrilateral. And so let's just remind ourselves, what did we learn about parallelograms? Well, the definition says that their opposite sides are parallel. Okay, and then we just proved that opposite sides are congruent. We proved that opposite angles are congruent. We proved that consecutive angles, right, same side, they must be supplementary. Okay, and then we just proved today that the diagonals bisect each other, right? Tick, 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 tick. Right, the diagonals bisect each other. Okay, so I don't want you to forget that actually what we're learning today, rectangles and rhombuses, they are also parallelograms. So all of these things apply to rectangles. All of these things apply to rhombuses. A rhombus is a parallelogram. A rectangle is a parallelogram. So you could say all the same things. And a square is a rectangle and a rhombus combined. That's just my son crying in the background. Don't mind that. So let's go ahead and try to find out some special features of these two, though. So go to the website that is linked on Google Classroom. It says Intro to Rhombuses and Rectangles. Just click on that goo.gl. And so what you can see is, just you can play around with it for a little bit. So again, this is a rhombus. You can see that the opposite angles are congruent, just like a parallelogram. But if you move it around, you can see a few other things here. So maybe pause this video and just try to play around with it, try and figure it out. What is the special features? And I forgot to even give us the definition. A rhombus has, by definition, all four sides congruent. Okay, that's what it means to be a rhombus. Tick, 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 tick. Okay, a rectangle, by definition, has all angles 90 degrees. Okay, so this is a rhombus, this is a rectangle. So if you put it together, you get a square, right? A square has all sides congruent like a rhombus, and a square has all angles 90 degrees like a rectangle. So a square is a rectangle, a square is a rhombus, a square is a parallelogram. Right? A rectangle is a parallelogram, a rhombus is a parallelogram. So there you go. So let's examine what are the special features. Notice how they always have to do with diagonals. So let's check that out. So notice here, these angles here get sliced. Look at this, 34, 34, 55, 55. It looks like no matter what, this gets sliced in half. So what we can say is that the diagonals bisect the angles fully, right? They slice it in half. That's for the rhombus. Additionally, you can kind of look at this angle here and maybe take a guess, but I'm just going to put it in there. Diagonals of a rhombus are 90 degrees. They are perpendicular. So notice how no matter how much I move it, this is going to be 90 degrees. Okay, 90 degrees. So those are the rhombus special features. Okay, so each diagonal is an angle bisector. Okay, each diagonal slices the angle in half, and the diagonals are perpendicular. Okay, those are the two special features. Check that out to confirm. So let's look at the rectangle now. Notice here, this is not 90 degrees, so it does not have the same feature. I could try to check. You could see, oh yeah, that's not 90 degrees right there, so that is not the same thing as the rhombus. And you can see clearly these are also not angle bisectors, so it's not the same features, but what I've shown here is that this diagonal here is exactly the same as this diagonal here. So FIHG, you can move it around, you could see that the diagonals themselves are congruent. The diagonals are congruent, and we'll prove both of these. Notice that's not true of the rhombus. This is not equal to this. You can check it by looking at the length here. Let me find the distance. This distance here, 7.74, is not the same as this distance here, 6.05. Right? So this does not have the same features. These are always going to be the same. So let's write that down. The diagonals of a rectangle are congruent. Okay? So, by the way, again, for your quiz, you're not going to have to memorize all of these. Your quiz is just basically going to be a proof, but I want to practice using these, and maybe you'll have just a few very simple questions, but you want to memorize all the detail features because it's too short a time. All right, so let's go ahead and take a look at these. Let's solve for some, and I'll leave some for you to do. Solve for the missing angles. All right, so we're trying to solve here. So let's notice I do not have right angles, but each is a parallelogram, so I know that's at least a parallelogram. And what I notice, I've got this tick, 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 tick. All sides are congruent. So think again, what is the name of the guy that all sides are congruent? It is a rhombus. So this is a rhombus. So we can use all the special features of a parallelogram, these four, and we can use the fact that each diagonal is an angle bisector and the diagonals are perpendicular. So to solve, let's take a look here. Because, let's take a look at this triangle right here. Look at this triangle right here. Because it's a rhombus, notice you have got yourself tick, tick. That's not, we didn't have that before, but we can see that we've got ourselves a nice isosceles triangle. So we can just think about this as being the base angles theorem. I can just go ahead and put arc there. All right, so 120 degrees plus x, right? You can call this x and x. So 120 degrees plus 2x must equal 180, right? This plus this plus this equals 180. So subtract 120 from both sides. 2x equals 60. So these two x's must both equal 30 degrees, right? This is 30 degrees, and this is 30 degrees, right? Because if you check, 120 plus 30 is 150, plus 30 again is 180. Now here's the part where it's nice and easy. You could actually solve it again, because this is 120, opposite angles are congruent, right? This is still a parallelogram. It has all the same features. And then I could do the exact same thing here, but I actually can save myself time because each diagonal is an angle bisector. This slices this in half, so you can actually just put an arc here as well. So this is also just 30 degrees. This is 30, 30, and this is 30, 30, right? Angle bisector. Remember, this is what we're saying here. These are the same. No matter what I do for the rhombus, these are the same, right? These are the same. It's an angle bisector. So we are making use of that fact. Okay, so I want you to try number 2 on your own. Again, use the fact that it looks like we've got tick, 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 tick. All four sides congruent. Think to yourself, is that a rectangle or is that a rhombus where all four sides are congruent? What special features? Okay, let's do number 3 together though. So this time I've got both diagonals. It's a parallelogram. It was given to me as a parallelogram. I've got tick, 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 tick. So let's think to ourselves, what can we do as I try to get this to focus again? Focus, there we go. All right, so this thing is pretty tricky unless we remember one thing. A rhombus, the diagonals are perpendicular. Perpendicular, which means they come together at 90 degrees. 90 degrees right there. Okay, so again, you could see that right here, this was 90 degrees. No matter what we do, it is so. Okay, so let's go ahead and try to figure the rest of these guys out. So if this is 50 and this is 90, let's go ahead and take a look at this triangle right here. That means that this guy right here must be 40, right? Because of the triangle angle sum theorem. So moving forward, what can I do with this? Well, there's a few things. Because, again, it's an angle bisector, I could say that this is also 40. Okay, so then from here, I've got a nice thing. I can actually go and say, all right, a couple things. I could look at this because this is a parallelogram, right? So you can always go ahead and add the parallel sides. I can think of these two as alternate interior angles. So this is also 40 degrees. Or, additionally, another way I could have thought about it was I could look at this triangle right here. This is a big isosceles triangle, so I could think of these as base angles, right? So it could be alternate interior or base angles of an isosceles triangle. But either way, I get 40. From there, I remind myself that the diagonals are perpendicular, so I've got this 90 here. And the rest falls into place. 40, 90, this must be 50. And again, you could have actually solved that by looking at this isosceles triangle. These are the base angles. And so you can see there's many ways to find these. Okay, angle 2. Again, I could say 50, 40, 90. So this must be 50, right? I could think of these as being an angle bisector, right? Because the diagonals are angle bisectors. So I could think of this as 50-50. Or finally, I could even do alternate interior angles 50-50 here. So you can see there's many ways to get these answers. Go ahead and try number 2, and then we'll move on to the next one. So pause the video, try number 2. All right, so let's take a look here at number 4. So number 4 here, I can see that this is a 90-degree angle, and because this was given as a parallelogram, I can go ahead and say it's a parallelogram. Remember, parallelogram has all opposite angles being congruent, so this is also 90. And we know that same side are supplementary, so 90 and 90 are supplementary. And I can go ahead and fill this in as well. So in other words, if I just know that this one thing is 90, I know that this must be a rectangle. Okay, so let's figure out all of these guys. And the trick for the rectangles is to remember the one special feature is that the diagonals themselves are congruent. It's not just they bisect each other, it's that they're fully congruent with each other. Okay, so that means that, like right here, this is fully equal to this. Okay, so what that means is that I can put a tick, tick, and then instead of putting tick, 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 I can just put another tick and another tick because they're fully equal to each other. Okay, so what that means is I've got a nice isosceles triangle right there that I can go ahead and do my base angles theorem. So if this is 15, this is also 15. Why do I care? Because this angle 1 right here, if this is 15, that is going to be 75. Right? That is going to be 75. Right? 15 plus 75 makes 90 degrees. Okay, from there, let's think. Because this is still a parallelogram, I've got my alternate interior angles right there. So this is going to be 15, and this is also going to be 15 degrees. Okay, so this is also 15 degrees. So I could find angle 4. I could find angle 4 by just saying 15 plus 15 plus the measure of angle 4 equals 180. Okay, so basically 30 plus the measure of angle 4 equals 180. So the measure of angle 4 equals 150 degrees. Okay, so a measure of angle 4 is 150. How do I find angle 2? There's a few different ways. You could say that because this is 15, this has to be 75 right here. And so I could find 75, 75, and this. Or I could say that 4 and 2 make a nice linear pair, so 180 minus 150. So the measure of angle 2 equals 180 minus 150, because this is 150. We get 30 degrees. Okay, so you go ahead and try number 5. Again, this is a rectangle because this is a parallelogram. Okay, so think to yourself, you know it's a rectangle because of you can say that this is 90. Think about why you can say that. So see if you can figure out the rest of these guys. Okay, and then we'll try number 6 after this. All right, number 6. Find the length of FD in this rectangle. So remember, the key feature of a rectangle is that this diagonal is exactly equal. The diagonals are congruent. So I can say 2y plus 4 equals 6y minus 5. And then from there, it's just some simple algebra. So 4 equals 4y minus 5. 4y equals 9. And so from there, we divide by 4, we get y equals 9 over 4. So let's go ahead and plug into FD. So 2, FD equals 2 times 9 over 4 plus 4. Remember, we can just put this over 1. So we get 18 over 4 and plus 4. Okay, so that's going to give me 18 over 4. Remember, I have to put this as a common denominator, so 16 over 4. You know what? Let's just not, you don't have to do this one. We don't have enough time. So The answer to this one is yes, because they bisect, and yes, because they are congruent, but I'd rather you do the proofs. We have a lot to do today, so you can do this, but 34/4, yeah. All right, let's move on to our last two, because I want us to focus on those. Okay, so let's do one of these proofs about the rhombus together. And so we want to prove, again, we want to prove that if we have a rhombus, right, that's a parallelogram, that's a special parallelogram, that's a rhombus, prove the diagonals are perpendicular. So I want to prove that this is 90 degrees here. Given a rhombus, let's just make it easier for ourselves. Let's just prove one of them is 90 degrees, because, so let's prove the measure of angle BEA is 90 degrees, because then all of them are going to be 90 degrees, okay? All we know is we have a rhombus, right? So let's just write that. We have a rhombus, A, B, C, D. Okay, so think to yourself, what is the definition of a rhombus? It's a parallelogram, right? So you can add, it's a parallelogram, you can add these, but what else is special about a rhombus? Think if you can remember it before I put it down. What does a rhombus have? Rhombus has all four sides congruent. Let's go ahead and add that as well. Tick, 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 tick. Okay, so we can say all sides are congruent, right? That's the definition. Okay, so to get this to be 90, my hint is, let's prove, instead of, again, the big triangles here, let's prove this triangle here congruent to, make it in green, this triangle here, right? Because if I prove these two triangles congruent, then by CP/CTC I can get these congruent, and then I could say that they'd be 90. So let's think to ourselves. I've already got this tick and this tick. What else can we say? I can say AE is congruent to AE by the reflexive property. So I'm going to put that. And for the last one, let's think here. There's a couple things you could do, but I think the easiest one is to remember that this is still a parallelogram. And so thinking back to a parallelogram, what do we know about the diagonals of a parallelogram? They bisect each other. They slice each other in half. So, of course, you have tick, 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 but the other thing we have is tick, 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 tick. And so by doing that, let's just go ahead and add that. BE is congruent to ED, right? Because the diagonals bisect, right? It's still a parallelogram, okay? And so by doing that, I can prove these two triangles congruent. So I can say triangle AEB is congruent to triangle AED by SSS, right? SSS. Okay, now that I've proven the triangle's congruent, I can say all the parts are congruent, including this right here. So I can say angle AEB is congruent to triangle AED. Right, that's CP/CTC. Right? Corresponding parts of congruent triangles are congruent. But if we look carefully, if these are equal to each other, but together they make 90 degrees, what two numbers do this have to be? It can't be 80 and 80, that'd be 160. It can't be 70 and 70, that'd be 140, right? They both have to be 90 and 90. That's the only way to make two numbers being equal, adding up to 180. So we can say that the measure of angle BEA equals 90 degrees because congruent supplementary angles must be 90 degrees, right? Angles that are both congruent and make 180, they both have to be 90 degrees. So we have just proven if I've got a rhombus, I can guarantee that these diagonals are perpendicular. Okay, so I've done that for you. What I want you to do then is to finish off this little exercise here by proving the rectangle. If I have a rectangle, prove to me that the diagonals are congruent. So in other words, if I've got a rectangle, let's just go ahead and add all these things. All I know is that these are 90 degrees, right? I want to prove that AC equals BD. Okay? And so think to yourself, all I know is that it's a rectangle. What does it mean to be a rectangle? I've given you that. So think to yourself, how can I prove that this whole thing, so not just this little half piece that we've been doing mostly, is equal to this thing right here. Okay, so that is left up to you. You have the rest of the period to try and finish these. Remember, for your quiz, it's going to be pretty much just one proof, like either parallelogram, rhombus, or rectangle. Since we haven't talked too much about rhombuses and rectangles, I won't make you memorize these. I'll give you this information if you need it. But it's going to be some kind of proof based off quadrilaterals with maybe a tiny couple problems elsewhere, but that's the main idea. So please practice all of these, and then we can answer a few questions on Friday, and then we'll take the quiz. Okay, good luck.